So before we begin with lesson 3.3, we want to go over our prep skills. So one thing we want to remember is that we can only add things that are alike. So if we look at this expression, 10k and minus 3k are similar. So if you add them together in total, you have 7k. The 8 and the 4 are similar, so you can add them together to get 12. And the next expression, you've got 4n, another 11n, so in total you have 15n. You have a negative 7n, a minus 4n, in total you've got negative 11n squared. And then finally the 7's alone, there's no other just plain constant terms, so you just bring that down by itself. Okay. So that's our first prep skill we want to use. Our next one is we want to remember how to evaluate expressions. So we saw with our bank accounts, we had the future value formula. So the amount was equal to the principal times 1 plus the rate times time. So if we have a $5,000 initial investment, that's the value of P. Suppose we have a 6% interest rate. You want to put that as a decimal, so it's 0.06. And we want to see what the value of this account is after 5 years. So T is equal to 5. So in the formula, you replace each of those components. So the P is 5,000, the 1 stays alone, R is 0.6, and then the time is 5. So if you actually compute that, you'll see that in 5 years' time, you'll have 6 years, $6,500 in your account. Okay. The last thing we want to remember how to do is we worked with these linear equations. So remember, you're going to start with your initial value. You're going to add that rate of change, which is the slope, and then you have some variable that represents what's changing. So that's your input value. And that will give you the output. So suppose you start a job making $11 per hour. That's your initial amount. It's that y-intercept. You're going to get a raise of $1.25 per hour every year. So if we want a formula to figure out our wage after T years we started, you begin at that initial value and you add that increase, which is $1.25, and you multiply that by the number of years. So if you want your wages after you work 7 years, you can just plug in T equals 7 into this formula. Okay. So we're going to utilize this to help us kind of solve equations. We've dealt a little bit with setting up equations, evaluating equations, but we want to come up with some tools to help us solve them. So the first thing we're going to look at together is kind of a key idea of what's the difference between an equation and just a statement. So you can make statements in your everyday life, like this one, New York City is the capital of Guatemala, and 8 equals 5. They're statements, but they're going to be false. Another statement you can make is there are over 1 million distinct species and animals that have been cataloged and named. And then in a math one, you could have 13 minus 10 is 3. So those ones are true. So we want to look at that key difference between those two. We want an equation that states that two quantities are equal, so they are actually true. Like in this case that we have 8 equals 5, that's not a true statement. We don't want that. So we want things to always be true. So if we look at an example, the statement below contains a variable quantity. Is it always true or is it always false? So the number of hours you spent on homework this week is 14. So this is not always going to be true, but it's not always going to be false either. So this one is actually just neither. Okay. So it could be true, but it could be false. Some weeks you might spend more, some weeks you might spend less. Okay. So in that case, it's not an equation, it's something that's called a conditional equation. It's true in some instances, but not the other. So sometimes there might be more than one possible solution to the equation. If you have a value that does work, it's called a solution. If you have a set of numbers that make the equation true. That's the actual solution. So you can have more than one correct answer, and you want to be able to find all of them. Now, most of the time, you're not going to have a simple equation like h equals 14. So if we make it more complicated, like negative 12y plus 17 equals 2y minus 11, and you can do a whole bunch more stuff, we got to figure out ways to actually solve this. So we want to go through and see what tools do we have to solve these. So we know 5 equals 5 is definitely true, but 5 equals 10 is false. So we want to take both sides of the equation and we're going to multiply by 2. So if we start with 5 equals 5 and we multiply both sides by 2, you get 10 equals 10, which is still a true statement. So you started out with something true, you ended with something true. When you take 5 equals 10, that's a false statement. Multiply both sides by 2, you get 10 equals 20. Still keeps it false. So you started it true, you kept it true. You started with false, you kept it to false. So when you multiply both sides of the equation by the same number, it's not going to change the solution. Okay? Now if we have the equation 1 foot equals 12 inches, we know that's true. And if we have the statement 3 feet equals 36 inches, we want to see, is that true? So why is it? Well, we're starting with 1 foot. We want to get to 3 feet. So let's go ahead and just multiply both sides by 3. When you do that, 1 times 3 gives you 3 feet on the left-hand side, and 3 times 12 is 36. So you get 36 inches on the right-hand side. So by multiplying both sides by the same number, it still results in a true statement. So multiplying by 3 on both sides won't change the truth value. Okay. Now, however, if we do multiply by 0, you can cause a bit of an issue. So let's start with 2 statements. We've got 1 mile is 5,280 feet. That's a true statement. And we've got 1 yard equals 1 meter, which is definitely going to be false. So we're starting over here with true, starting over here with false. We're going to take both sides and multiply it by 0. So 1 times 0 is 0. And then 5,280 times 0 is still 0. We still landed with a true statement. However, over here, when we started with false, when you multiply by 0, you get 0 yards equals 0 meters, which is now going to be a true statement. Okay? So we don't want to multiply each side of a conditional equation by 0 because it can turn false equations into true ones. So we can turn false equations true. When we multiply by 0. So be careful, you don't want to do that, but if you multiply by any other non-zero number, you're good. So this is our first tool we have for solving equations. We can multiply both sides of an equation by the same number or expression as long as that number or expression isn't equal to 0. So we want to use that above answer to solve this equation. So we've got d divided by 360 is 0.35. So if we take both sides and multiply by 360, we'll still get a true statement, and that will also cause the 360s to cancel. So what we do to one side, we have to do to the other. So this gives us d is equal to 0.35 times 360, which is 126. So we get this solution, and we want to check it's true by plugging it back into the original equation. So D is 126. If you take 126 and you go ahead and divide it by 360, yes, that's going to equal 0.35. So you get a true statement, okay? So we want to make sure there are no other solutions because potentially there could be. But what we did by multiplying by 360 doesn't change the solutions. And it needed to tell us that D was exactly this number. So it has to be the only possible one. So why is this the only solution? Well, multiplying both sides by 360 will not change the solutions. So since only one solution, or that produced only one solution, it must be the only one. Okay. So we have one solution to this particular equation. Right. So let's go ahead and keep working. Now we'll try to find another tool. We know 1 minute equals 60 seconds is true. So is it also true half a minute is 30 seconds? And how did you produce that? Well, yes, half of a minute is 30 seconds. So the way we got there is both sides were divided by 2. So we divide this by 2, we divide this by 2. And that gives us half a minute is equal to 30 seconds, which is also true. So this is our next tool. If you start with a true conditional statement, we can multiply or divide is our new one. We can divide both sides of an equation by the same number or expression as long as it doesn't equal 0, because you can't divide by 0. So if we want to solve 5x equals 60 using this, you want just x on its own, so let's go ahead and divide by 5. Because 5 over 5 will cancel, and this will give us that x has to equal 12. So we can check that by plugging it in. You get 5 times 12 does equal 60. So yes, we have the correct solution. Okay. Another thing that we can do to solve something is when we have proportions, we can use something that's called cross-multiplying. So in this specific example, d over 360 equals 35 over 100. Cross-multiplying is not necessarily the best tool because we could just multiply both sides instead. But the idea is you can get rid of the fractions by going ahead and multiplying the pieces that are across from each other. So you would take the d and times it by 100, and you would take the 360 and times it by 35. We're going to go ahead and solve this by cross-multiplying. So we're going to get 100 times d is equal to 35 times 360. So you multiply the pieces that are across from each other. So you get 100d is equal to 12,600. And now to solve for d, we'll bring in that second tool. You divide both sides by 100 to make those cancel. And you get d is 126. So you end up with the same result as you would from cross-multiplying, okay? So let's go ahead and use that to solve another proportion. We've got x over 12 is equal to 15 over 36. So multiply what's across, so the x and the 36, and then multiply the 12 and the 15. So we're going to get 36 times x is equal to 12 times 15. So that gives us 36x equals 180. And then to solve for x, you divide by 36. So we get x equals 5, which again you can check by plugging it back into the original expression. Okay. So now let's work on our next tool. So we have to be a little bit careful when we have addition or subtraction. So we know 1 minute is equal to 30 seconds. So is it okay if we just add 3 to both sides of the equation, resulting in 4 minutes equals 63 seconds? So no, we can't do this. 4 minutes is a lot longer. So 4 minutes is not equal to 63 seconds. Okay. So we added 3 minutes to one side, but 3 seconds to the other. So we didn't add the same quantity. Okay. So we didn't add the same quantity. To both sides. On one side we added 3 minutes, on one side we added 3 seconds, which are very different things. Now if we do add that same quantity, when we add 3 seconds to both sides, 1 minute, 3 seconds is equal to 36 seconds. Yes, this is okay. We're adding the same thing to both sides. So we're adding the exact same quantity. To both sides. Okay. So that is our next tool. We can add something to both sides of the expression, but it has to be exactly the same thing. So we can add the same quantity to both sides of an equation. So if we look at this example, x minus 42 equals 70, let's go ahead and add 142 to both sides. So you get x minus 142 equals 70. Let's add 142. So the negative 142 and positive 142 cancel. That means we have to add exactly the same quantity to the other. But this will cause the 142s to cancel, and so we get x is equal to 212. So you can check your answer by plugging it in. X is 212, so we get 212 minus 142 does indeed equal 70. So we are okay. Right? Now our last tool deals with subtraction, and it's very similar to addition. 3 feet is 36 inches. If you subtract 5 inches from both sides, you want to see, do we get a true statement? So we're starting with 36 inches is the same as 3 feet. Now I can't quite subtract 5 inches from that. So I'm going to start with just this 36 inches, or 36 inches. If we subtract 5 inches, those are like quantities, so we can simplify it to 31 inches. Now, if I take the 3 feet and I subtract 5 inches, I need to be a little bit careful. So 3 feet is the same thing as 2 feet and 12 inches. And I'm subtracting 5 inches. So that gives us 2 feet, and now we can combine the like pieces. So 12 inches minus 5 inches gives us, we have 2 feet and 7 inches. Okay? So by subtracting 5 inches from both sides, we get 31 inches is the same thing as 2 feet, 7 inches, which is still true. Okay? So our next tool is you can subtract the same quantity from both sides and still get a true statement. So we've got n plus 1,361 is 2,094. So we're going to go ahead and we're going to subtract that quantity to make them cancel, which means you have to do the same thing to the other side. So by doing that, you'll get n is 2,094 minus 1,361, which simplifies nicely to 733. Writing the wrong thing. Right? So now you can test it by plugging it back in. If you take 733 and add 1,361, you do indeed get the 2,094 back. So this is kind of our steps for solving equations. We've got these 4 tools. You can add and subtract the same quantity. You can multiply and divide by any non-zero number. We can use those to actually solve linear equations. So what you want to do is you want to simplify both sides if you possibly can. Get rid of parentheses. You don't want to deal with any of that. Group all of your like terms. Then you're going to go ahead and add or subtract quantities to kind of isolate that variable, and then use multiplication and division when necessary. So let's go ahead and work back with the same ice cream cone company that we've been dealing, or snow cone company we've been dealing with. We had that graph for the profit function. So remember, when you sold no snow cones, you still were in the hole $245, because that's how much you lost. And we came up with an expression for the profit in that last lesson. So the profit starts out at negative 245, that's your fixed cost, and then you gain 63 cents per snow cone. So we're going to go ahead and work with this expression. So given the fact that x represents the number of snow cones sold, what should we do to find the profit from selling 150 snow cones? And then describe what you do, find your profit. So x is the snow cones. We're going to go ahead and we're going to replace x with 150, because that's what the snow cones is. So the profit for 150 snow cones is that initial fixed cost, so you're automatically in the hole $245, and then you get 63 cents per snow cone. So we want to see what the profit is for 150. So this tells us our profit is negative 150.50. So even when you sell 150 snow cones, you're still losing $150.50. And if you remember back to the last lesson, when we wanted to estimate what the profit was, we just looked at 150 snow cones, where do you hit that profit function, which was around negative 150. So we estimated the profit was negative 150, which is really close. So we estimated negative $150 was our profit, so we were pretty close. Okay. We were just off by 50 cents. Right. So now let's keep working. Given P represents the profit, what should we do to find the number of snow cone needed to make a profit of $50? So now P is our profit. We're going to go ahead and we're going to replace P with 50 instead. And you want to find the number of snow cones from this. So you would get 50 equals negative 245 plus 0.63x. So now we only have this one variable left. We can use the tools we learned in this lesson to solve this equation. That's exactly what this next one does. We want to figure out how many snow cones. So we need to solve the 50 equals negative 245 plus 0.63x. So remember, your goal is to isolate the x variable. So I'm going to first move all of the constants to one side. So I need to get rid of this 245. So I'm going to add it to both sides. And that gives us 90 is equal to 0.63x. So to get x on its own, you divide by the 0.63, which means you have to do it on the other side as well. So you're going to find out by rounding, x is around 468.3, okay? Because the 0.63's cancel. So this is representing snow cones. You can't sell 0.3 of a snow cone. So we need to sell 469 snow cones to make a profit of $50. Okay. So now you can check your answer and plug it back in. You want to see, does it make it exactly true? And what does that mean about our company making $50? So if you plug this back in, you get 50 is negative 245 plus 0.63 times 50. So that's 50. If you plug that into your calculator, it's 50.47. So we're saying 50 is equal to 50.47. This is technically false. It's not going to check. It's not going to work exactly because we rounded. So since we rounded, this won't be exact. Okay. So what that means is you can't actually make a $50 profit. If you plugged in, oh, I put the wrong number in here. So what we want to do is we want to plug this number of snow cones back in. So we get 50 is equal to negative 245 plus 0.63, and then the number of snow cones we need to sell is 469. So if you plug the right-hand side into your calculator, you're going to see it's 50.47. So we're saying 50 equals 50.47, which is technically false. So it doesn't check because we rounded. So that's going to happen when you can't get that exact number. So if you tried 468 snow cones, it would be 49 point something. So I can't sell a fraction of a snow cone. There's no way we can actually make exactly a $50 profit. So we cannot make exactly a $50 profit. We can get close, but we won't be able to make this because we can't sell those fractions of a snow cone, which is fine. Right? Now we want to do the same type of thing. We want to find the profit if 700 snow cones were sold. So remember, this 700 is dealing with the snow cones. That's the value of x. So the profit is negative 245 plus 0.63 times the number of snow cones, which is 700. So if you plug this into your calculator, you're going to see the profit is 196. Okay. Now we want to use the same equation to figure out how many snow cones they need to sell for the profit to be 400. So the profit is the value of P, so you're going to replace P by 400. And that will equal negative 245 plus 0.63 times the number of snow cones. So the number of snow cones is unknown. That's what we're trying to find, which is why the x is staying as the variable. You want to see what x makes this equation true. So same technique, you've got to solve for x. We want to isolate x, so let's add this constant to the other side. So those two cancel. 400 plus 245 is 645, and that's equal to 0.63x. To solve for x then, you divide by the number out front. So those cancel, and we're left with x. And on the right-hand side, if you plug that into your calculator, you're going to get about 1,023.8. Okay. So again, you can't sell a portion of a snow cone, so we need to sell rounded up. 1,024 snow cones to make a $400 profit. All right, so now we're gonna kind of put that in words. In either one, it really didn't matter what was on that left-hand side. When we went to solve these equations, the first thing we did was we added 245. The second thing we did was divided by 0.63. Same thing in the prior equation for a $50 profit, you added 245 divided by 0.63. So in both of these, first we added 245 to both sides, and then divided both sides by 0.63. Okay. So we're going to perform those same steps, but we're going to solve the equation for x with an arbitrary p. So basically, my profit at any point is given by this equation. I'm going to solve this for x, so it makes it a little bit easier to now know how many snow cones you need to sell. So I do the same process. You add 245 to both sides to make these cancel. Now p is a variable, so you can't combine it with 245. All you get is p plus 245. And that equals 0.63x. So first step was add 245. Second step, divide by 0.63. So that gives us x is equal to p plus 245 divided by 0.63. So now instead, if I ask you how many snow cones you need to sell to make a profit of $70, you would just plug in 70 for p. So you can use the first equation, this one, if you want to figure out what the profit is for a number of snow cones, or now I can use this if I'm given the profit and want to find how many snow cones we need to sell. Okay? So we solved just a regular equation to get through this. We had x is equal to p plus 245 divided by 0.63. So if we wanted to solve for each of these, I'm given the profit in these instances. We're going to plug that in for p and solve for the value of x. So I'll do this first one off to the side. If you want a profit of $0, p will equal 0. So x will equal 245. Let's even back it up a step. It'll equal 0 plus 245 divided by 0.63. So the number of snow cones you would need to sell would be 389 to break even. If you plug in p is 250 into this expression, you'd see you need to sell 786 snow cones to make 250. To make $500, you have to sell 1,183 snow cones. And to make $1,000, you need to sell 1,977 snow cones. Okay? So what this does is instead of starting with that original equation where we had profit on the left-hand side that we had to continuously solve, I can now just plug in P a lot easier. So by solving for X instead, it allowed us to plug in profits easier. And find the number of snow cones without having to solve an equation every time. Okay. So we're going to go back to our temperatures. We learned two different formulas for converting temperatures. First one is we have F is equal to 9/5 C plus 32. So early in the course, we worked with two equations for converting temperatures. We had F is equal to 9/5 times C plus 32, and we had the second equation, which was C is equal to 5/9 times F minus 32. So what we want, if you kind of remembered, F was standing for Fahrenheit, C was standing for degrees Celsius. So we're going to start with a formula that calculates the degrees Fahrenheit in terms of the degrees Celsius. And we're going to try to do the same thing we just did in the prior example. And we're going to go ahead and see if we can solve for C. So I want to solve this for C. First thing I need to do is I need to isolate the C variable. So we need to subtract this 32. So first, we're going to subtract 32 from both sides. So we're starting with F equals 9/5 C plus 32. We're going to subtract 32 from both sides. And that gives us F minus 32 is equal to 9/5 times C. So to solve for C, we need to now get rid of this 9/5. So if you multiply by 5/9, it'll cancel this out. So we're going to multiply both sides by 5/9, which is the reciprocal of this fraction 9/5. So we've got F minus 32 is equal to 5/9 times C. We're going to multiply both sides. So I have to multiply this entire expression by 5/9. Wrote the wrong thing here. This is 9/5. And I want to multiply this side by 5/9 as well. So what happens is the 5's cancel and the 9's cancel as well. So all you're left with is a C. And you get 5/9 times F minus 32 is exactly equal to C. So what this does is it actually gives you this other formula that we have. So this gives us the other formula. So both of them represent the same equation, they're just solved for different variables, just like we did in that last example. So the main things we kind of learn from this is when we're solving these equations where you've got two variables, you still pretend that the other variable is just a letter. It's just going to be some number, that's it. And you're still going to apply the same four techniques, add and subtract, multiply and divide. And those are our main tools we have for solving equations.